Dear students, in this video we are going to discuss about Euclidean algorithm. Euclidean algorithm is an algorithm which is used to find out the GCD of among two numbers. GCD is greatest common divisor. So this algorithm is used to find out the GCD among numbers. Euclidean algorithm is used for computing the greatest common divisor of two integers. When a and b are any two integers, that is, a should be greater than b, in such a situation, if r1 is the remainder when a is divided by b, r2 is the remainder when b is divided by r1, r3 is the remainder when r1 is divided by r2, and so on. And if rk plus 1 is equal to 0, then the last non-zero remainder rk is the GCD of a comma b. So if you want to find out the GCD of two numbers a and b, the first thing is a should be divided by b, and the remainder that obtained in that situation is take considered as r1. That is the first step. In the second step, what we have to do is b is divided by r1, and in such a situation r2 is the remainder. In the third case, what we do is R1 should be divided by R2 and R3 is the remainder in that case. Likewise, we should follow until we obtain a zero remainder. So then the last non-zero remainder should be the GCD among the corresponding numbers. We will see an example. So let A equal to B Q plus R, where A, B and A, B are the dividend and divisor. Q is the quotient and R is the remainder. So we can write each and every number in the format A is equal to BQ plus R. So GCD of AB should be equal to GCD of BR. So Euclidean algorithm stops whenever we obtain a remainder which should be equal to 0. We want to obtain the GCD of A and 0, it should be equal to A. Now we are going to compute the Euclidean algorithm for finding out the GCD of 1701 and 3768. So we have to express this GCD, and for that we are using the format A equal to BQ plus R. So in this situation we have to assign the largest value as A and smallest value as B. So here A is assigned with 3768 and B is assigned with 1701. Now what we are going to do is we have to divide A by B, that is 3768 divided by 1701. While we are doing that step, we obtain 2 as the quotient and 366 as the remainder. So we can write the same as 3768 is equal to 1701 into 2 plus 366. 366 is the remainder and Q is the quotient. In the next step, what we do is we have to consider the B value, that is this position 1701. 1701 should be on the left hand side. We have to divide 1701 with this remainder 366. So 1701 divided by 366, it should be equal to 4 as the quotient and 237 as the remainder. So we can write it as 1701 equal to 366 into 4 plus 237. Now we move on to the third step. In the third step, we move 366 to the left hand side, and we have to express 366 divided by 237. So in that situation, 1 is the quotient and 129 is the remainder. So we write it as 366 is equal to 237 into 1 plus 129. 1 is the quotient and 129 is the remainder. Now in the next step, 237 move to the left hand side. 237 should be divided with 129. So 129, 237 divided by 129, 1 as the quotient and 108 as the remainder. So 237 is equal to 129 into 1 plus 108. In the next step, 129 should be on the left hand side and we have to divide 129 by 108. So 129 is equal to 1 is the quotient and 21 is the remainder. So we can write it as 129 is equal to 108 into 1 plus 21. In the next stage, 108 should be on the left hand side and we have to divide 108 with 21. So we obtain 5 as the quotient and 3 as the remainder. So we can write it as 108 is equal to 21 into 5 plus 3. In the next stage, 21 will be on the left hand side. So 21 is equal to 21 should be divided with 3. So 21 is equal to 3 into 7 plus 0. So we obtain a 0 remainder. Now what we have to do is we have to identify the last non-zero remainder, that is 3. So in this situation, 3 is assigned as the GCD of 1701 and 3768. The last non-zero remainder which is obtained during Euclidean algorithm is 3. So 3 is the GCD among these numbers 1701 and 3768. Hope you understood this lecture. Thank you.